Let's get started with our opening exercise. Part A says, in the morning, Harrison checked the temperature outside to find that it was negative 12 degrees Fahrenheit. Later in the afternoon, the temperature rose to 12 degrees Fahrenheit. Write an expression representing the temperature change. What was the afternoon temperature? Well, first I noticed that this is a word problem, so I'm going to want to use cubes to help me annotate this problem. So I'm going to start by circling the numbers or units that I see. Harrison checked the temperature outside and found that it was a negative 12 degrees Fahrenheit outside. Later in the afternoon, the temperature rose. I'm going to box out there where it rose, because I know that to rise is the addition operation by 12 degrees Fahrenheit. Write an expression representing the temperature change. Underlining one question. What was the afternoon temperature? So I see two different sets of underlines, so lets me know I have two questions to answer. Let's handle writing an expression to represent the temperature change. When I have my beginning temperature, and my beginning temperature was that it was a negative 12 degrees Fahrenheit. And then it tells me in the afternoon that temperature rose. Rose is going to be the operation of addition. Rose to be 12 degrees Fahrenheit. I'm using a number line or a calculator to add negative 12 and 12. What would my ending temperature be? And my afternoon temperature or my ending temperature would be 0 degrees Fahrenheit. Let's go to part B. Rewrite the subtraction as adding the inverse for the following problems and finding the sum. Remember, the word inverse means the opposite. So I want to rewrite each of these problems to show addition of each of the terms. I'll model I for you. If I see 2 minus 2, I know that that's the same thing as saying 2 plus a negative 2. And 2 plus negative 2 makes 0. How can I rewrite number 2? I'm going to say negative 4 plus negative 4 equals 0. When I see the subtraction of a negative, that means to do the opposite of a negative number. And the opposite of negative is to add. The opposite of negative is to add. Great, let's move on to number 3. The difference, the word difference is going to be subtractions, the difference of 5 and 5. I'm going to have 5 minus 5 to represent the difference of 5 and 5. But I do want to use the additive inverse, so I would rewrite that to say 5 plus negative 5, which is going to give me 0. All right, lastly, let's look at number 4. So I have G minus G. G minus G using the additive inverse would look like G plus negative G, which would leave me with 0. What pattern do you notice in part A and part B? Type your answers in the box. Be sure to jot down the answer that you've written in the box, but you should have said that. So again, that's the sum of a number and its additive inverse equal 0. Let's go on to exercise D. In exercise D now, we want to either add or subtract. 16 plus 0 gives me what? Yep, 16. 0 minus 7. How can I rewrite that using addition? It's going to look like 0 plus negative 7. And my final answer would be what? Negative 7. Negative 4 plus 0. What would that final answer be? Negative 4. 0 plus D. What will my final answer be? D. If I have nothing to add to D, then my answer is going to be D. What do you notice in parts I through IV? Yeah, you should notice that the sum of any quantity and 0 is equal to the value of the quantity. When I add 0 to any number, I get that number. Cool. Go ahead and find example 1 in your packet. In example 1, we want to write the sum and then write an equivalent expression by collecting like terms and removing the parentheses. So I've been asked to write the sum, and I know when I see the word sum, that means addition. First thing I'm going to do is jot down that expression. So that's going to look like 2x. I'm going to put my first expression in parentheses. And it says the sum of my next expression, negative 2x plus 3, is going to go in parentheses. Because I see addition in between all 3 of these terms, I know that I can use the associative property to regroup my like term. So I'm going to use the associative property to regroup this. That means I'm going to bring this 2x and this negative 2x to the exact same parenthesis. My equivalent expression is going to look like 2x plus a negative 2x. Now plus this 3 singularly by itself. When I combine my terms, I notice that 2x plus a negative 2x is going to leave me with 0. This 3 has nothing to be added to, so it's out by itself. Now I'm left with 0 plus 3 and the sum of 0 and 3. Final answer of 3. Go ahead and try part B on your own. Be sure to write out whether you're going to use the associative property or the commutative property to rewrite this expression. Final answer should be negative 7. Go to problem C. Problem C asks us to take the opposite of the quantity of 5x and 1. Opposite would mean if it's positive, it becomes negative, and if it's negative, it becomes positive. Because I see that 5x minus 1 is already positive, I'm actually going to be multiplying 5x minus 1 by a negative 1. I'm going to be multiplying that entire expression by a negative 1. So I want to do negative 1 times 5x minus 1 plus 5x. Remember when I see a negative 1 outside the parenthesis, what does that tell me happens to each term inside my parenthesis? Yeah, when I distribute this negative 1 inside each term in the parenthesis, a positive 5x becomes a negative 5x. And a negative 1 becomes a positive 1. So I'm going to use my parenthesis to keep that expression grouped. Which property do I want to use to bring these like terms into the same parenthesis? Yeah, I want to use the associative property. So I'm going to rewrite this expression saying that negative 5x plus 5x plus 5, 1. Going to leave me with 0 plus 1, which equals a final answer of 1. Let's go ahead and jump into exercise 1. At this point, make contact with your teacher to let them know that you're ready to work with a partner. Again, your partner needs to be at the same point in the lesson as you are. Make sure you're working example A and example B. You will only have 4 minutes. Go ahead. Let's jump right into example 2. In example 2, you have 3 different types of numbers. Let's pay attention to this first bullet. I notice that I see 3 over 4 times 4 over 3. What are these pairs of numbers called? Should have said that these are called reciprocals. What is another term for the word reciprocal? Another term for the word reciprocal is the multiplicative inverse. What happens to the sign of the expression when I convert it to its multiplicative inverse? In other words, does my sign stay the same or did it change? Take a look at these 3 examples if you're confused. Yeah, there's no change in the sign. Okay, so if I wanted to find the multiplicative inverse of negative 2, that would look like a negative 1 over 2. Sorry, you can see that if I want to find the multiplicative inverse of negative 2, that would look like a negative 1 over 2. What can you conclude from your pattern in the answers? So if I wanted to go ahead and multiply 3 over 4 by 4 over 3, what would my final answer be? Well, I know when I'm multiplying fractions, I multiply numerator by numerator. 3 times 4 gives me 12. Denominator by numerator, 4 times 3 gives me 12. 12 divided by 12 gives me 1. What about when I do 4 times 1/4? What would my final answer be? I'm going to turn 4 into a fraction. I'm going to multiply straight across, and I'm going to get 4 over 4. 4 over 4 gives me 1. Did the same thing with the third example, 1/9 times 9. And get 9 over 9, which gives me a final answer of 1. So again, the question is, what do you notice about the pattern? The product of a number and its multiplicative inverse is equal to what? 1. Earlier we saw that 0 was a special number because it's the only number that when we add it to another number results in that number again. Why is the number 1 also special? I said the number 1 is also special because when you multiply 1 by another number, you will get that number again. The property that makes 1 special among all numbers is called the multiplicative identity property of 1. All right, we have some more work to do. It says write the product and then write the expression in standard form by removing the parentheses and combining the like terms. Make sure you're able to justify each step. So I want to use the multiplicative inverse of 5 and 2x minus 1 over 5. Remember when I do the multiplicative inverse of 1 over 5, that means I want to take the reciprocal of that number. What does the reciprocal of 1 over 5 look like? Yeah, the reciprocal of 1 over 5 is going to be 5 over 1. I'm actually going to take that fraction and I just flip it. My numerator becomes my denominator and my denominator becomes my numerator. So now I want to write the product. Product means I'm multiplying these two terms by each other. So I'm going to multiply 5 times 2x minus 1 over 5. When I see this 5 outside the parenthesis, it tells me that I'm going to use the distributive property to distribute a 5 to each of those terms. I want to distribute that 5. That's going to look like 5 times 2x minus 5 times 1 over 5. Go ahead and evaluate this expression and write your simplified expression. So when I do 5 times 2x, I'm going to end up with 10x. And when I do 5 times its multiplicative inverse, remember I'm always going to get a 1. And these are connected with subtraction because there was subtraction in between them. So I get that my final answer. Go ahead and work B independently. By 1/2 by 2, because this is multiplicative inverse, I know I'm going to get 1. Alright, let's look at exercise C. Exercise C can appear tricky because I have a kind of complicated denominator. I see 1 over 3x plus 5 and 1 over 3. What would the multiplicative inverse of 1 over 3x plus 5 look like? It's going to look like 3x plus 5 over 1. Remember, my numerator becomes my denominator, and my denominator becomes my numerator. I now want to multiply that by 1 over 3. I'm going to use the commutative property to rearrange this so you can see what's actually outside the parenthesis at the front of my expression. So this actually says I'm doing 1/3 times 3x plus 5 over 1. I want to distribute this 1/3 to that 3 over x and to that 5. It's going to look like 1 over 3 times 3x plus 1 over 3 times 5. Go ahead and simplify this expression. We ended up with 1x plus 5 over 3. All right, take this space to summarize today's learning. You should have at least 2 bullet points written down around what you've learned today. Once you summarize today's learning, go ahead and find your problem set and get started. You can log out of your computer.